Hi, thanks for joining us for today's discussion of sustainable site design and construction. I'm Rebecca Joan Brown, and I'll be presenting the course today. Today we will be discussing sustainability options that projects may incorporate with respect to site location, topography, runoff, stormwater management, heat island effect, proximity to amenities, and public transportation. We will discuss how site factors fit into the three major LEED rating systems, as well as briefly discussing the necessary documentation and calculations. The IDNC and BDNC rating systems have SS Credit 2 in common, Development Density and Community Connectivity. In both cases, the credit is divided into two options. Option 1 is Development Density. To earn points for this option, projects should choose a previously developed site that is in a relatively dense neighborhood. In order to determine compliance, first determine the building's square footage as well as the site area. The ratio of these two must be at least 60,000 square feet per acre. You will then determine the density radius that you'll be using for the rest of the calculation. Convert the site area into square feet by multiplying the acreage by 43,560. The square root of this number is multiplied by 3 to determine the density radius. Look at all of the sites and structures within this radius. If the sum of the built area, including the proposed project, over the sum of the site area is greater than or equal to 60,000 square feet per acre, the project will earn this credit. This is worth 4 points for school projects, 5 for new construction in core and shell, and 6 for commercial interior projects. Green roofs are sometimes referred to as vegetative roofs, garden roofs, or living roofs. A green roof is a roof that is partially or completely covered with vegetation. Usually the vegetation is planted in containers, modular units, or bags that sit atop a waterproof subsurface. Rather than soil, an artificial growth medium is typically used that is lighter and provides more nutrition for the plants. While green roofs are more popular in Europe than in the US, their popularity is increasing as people realize the benefits they offer in terms of heat island reduction, stormwater runoff reduction, and insulation. Green roofs can also help to protect your roof surface from sun, wind, and water damage, thus reducing or deferring replacement and repair costs. As an additional benefit, the vegetation will also help to clean the air, reducing levels of carbon dioxide and some pollutants. Green roofs can be heavy, so designers should make sure to account for the extra weight when designing roof structures. When planted with native or adaptive species, the roofs should not need much more water than they will be able to absorb from rains, but there is still a bit more maintenance involved with a green roof than a traditional one. By preventing the rainwater that falls on a roof from flowing to ground level, projects can reduce the stress on other stormwater management interventions.